Welcome to the Public AI Cafe on July 19th. And today we present three speakers. It will be Nicola Messina. Hello, Nicola.
Hello. Hi.
Giovanni Puccetti. Hello.
Hello.
And Roberto Gallotta. Hello,
Hello.
Roberto. And my co-moderator is Emma. Hi, Emma.
Hi.
And I'm Carmen McWilliams, and I welcome you all. Thank you for coming, even it's summertime, and you might have better things to do. And this cafe is called First Presentation EvaLMM Evaluating LMMs on Common Sense and Factuality. That's the first presentation by Nicola and by Giovanni. Giovanni, both are from CIS. And then comes the second presentation today, which is called LLMAKER An LLM-powered design assistant for video games. This is presented by Roberto from University of Malta. So it's a real great program. And before we start, I must always tell you the rules. Please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for Media project opinion. And what's the cafe about? The cafe is an online forum to gain insights into the European AI scene. You can meet stakeholders here from various areas of AI research and application. And it's interactive, so we really would love when you send us your questions to the speakers. Me and Emma will read them to the speakers after the presentations. So please feel free. There is a tool in the menu for questions. Just write them, send them to us anytime you feel like asking. So once more, welcome. And now I will introduce the first speaker, which will be Nicola Messina. He is currently a researcher at the Artificial Intelligence for Media and Humanities of the Information Science and Technologies Institute of the Italian CNR in Pisa. He received his master's degree in computer engineering in 2018 at the University of Pisa and his Ph.D. in information engineering from the same university in 2022. He is presently researching deep learning methods for relational understanding in multimedia data, with particular emphasis on transformer-based architectures for effective and efficient cross-modal analysis and retrieval on images, text, and videos. He is also interested in attentive deep learning models for anomaly detection, visual counting, and open vocabulary object detection. So I welcome you, Nicola, and that I don't have to do in the middle. Also introduce Giovanni. I do it now because he's the second speaker for the first presentation. Giovanni Puccetti is a postdoc researcher at Information Science and Technologies Institute at the CNR, Pisa. He received his PhD in data science in 2023 from Scuola Normale Superiore in Pisa. His main research interests focus on large language models based on transformers and their impact on society. In particular, he is interested in mechanistic interpretability, continued pre-training, and adaptation to the Italian language. He is also interested in the detection of synthetic texts generated from large language models to mitigate their potential negative impact on society. So again, both of you, great that you're here. I will now make Nicola the speaker and the presenter. This takes a moment, so be with us. I will now make you the presenter. You should see a pop-up. Very good. We see your presentation, and we need full modus. Yes. Thank you. That's
okay. Thank you so much, Carmen, for the kind introduction. Yeah, I'm Nicola Messina. I'm a researcher at ISTI CNR. And today, together with Giovanni, we are going to present this mini project that was funded by A4Media, that is EvaLMM, so evaluating large multimodal models on common sense and factuality, actually for testing the abilities of large multimodal models to understand long videos in a factual way. So I would also like to thank Andrea Esuli and Fabrizio Falchi, that are the other guys behind this project, the other researcher that helped us a lot in the development of this project. So before going into the details actually of the benchmark that we constructed, I would like first of all to give you some introduction and motivation behind this work. So many of you probably will know even better than me large multimodal models. Large multimodal models are actually large language models plus vision capabilities. Even if, okay, with multimodal now we intend also, for example, other kind of modalities apart vision, for example, 3D, the 3D modality, or even audio. But in this presentation, I will refer to multimodal as the vision modality. So large multimodal models basically enable a chat-based interaction, and they recently achieved astonishing abilities in many image-based downstream tasks. For example, we can just ask the large multimodal model to describe the image, so solving the captioning task. We can ask the system to to ask some very specific question about the image, so solve some visual question answering task. We can also ask the system, for example, to count some instances of particular objects within the scene. So, for example, for asking how many yellow cars are there. And also, if properly fine-tuned, a system like this can also perform object detection and grounding. So we can ask the model to localize the yellow car, and we expect the system to reply with the coordinates of the 2D bounding box in a textual format, properly formatted. However, okay, this is very good, very nice, but LMMs still have a lot of problems, okay? And we identified, for starting with the idea behind this project, with this kind of limitation. So can they answer questions on hours of personal footage, okay, where personal footage we intend a collection of long-lasting videos, for example, that I collected in vacation, for example. So we have a lot of videos in my personal collection, and we would like to, for example, summarize something that we have seen during our visit to all the cities of our vacation. So we would like to understand what are the main destinations, and we would like the system to reply by summarizing that I like, for example, Sia places, and we would like also the system to understand what are these places, so name the proper names of the cities, for example, or regions, for example, Sicily or Naples. And okay, we would also like to summarize what we have seen throughout the whole video or the whole collection of videos. Here we are assuming that, okay, we have few or no metadata available. Otherwise, it could be an easy task if we have the times, the geolocalization, and so on and so forth. But there are cases in which the metadata is not available, okay, and we will see in a moment. In the limit, I would like to extend this reasoning to whole films, for example, so very long video streams, films, or TV series, in which we would like the system to understand what are the main characters of this film by just watching at the video and not accessing any external, for example, Wikipedia summary of the film. So, for example, understanding what's the name of some characters and so on and so forth, and when and where they are introduced within the video itself. Okay, why this is important? Because we have plenty of historical archives containing just raw videos from the past, a lot of years ago. For example, containing historical data, documentary shots about historical people, and so on and so forth. So, for example, we can imagine that we want to prepare a documentary on Winston Churchill using accessing an historical archive of more than, I don't know, 100,000 hours of videos. That lack of enough metadata, we don't have a lot of information apart from the video themselves. Okay, so we need a system that is multimodal by nature, that is able to interact and retrieve visual data using, for example, textual prompts. It should be content-based because we don't want to rely on metadata. And also we want the system to be interactive. So there is a continuous back and forth of interaction between the user and the system that replies to the user. Okay, so maybe many of you know CLIP, the CLIP model, that is a groundbreaking model for jointly understanding images and text. And with this kind of model, you can, for example, write some text and retrieve the most similar images to that text without any additional metadata available. So this is purely content-based. Okay, a lot of systems now are working with this architecture that enable a quick search of very huge video and image databases. However, CLIP has a lot of drawbacks. For example, it has some problems in handling long-tail concepts. It cannot understand hours-long videos, even the extension of CLIP that understand sequences of frames, that is videos. And of course, it is not generative, so CLIP by default cannot dialogue with the user, and so it is not interactive from that sense. So I would like to mention Visione, that is a system that we are developing within ISTI CNR, and actually is part of the use case 3 within i4Media, with which we collaborated also with the RAI, the national television, that proposed us some parts of the historical archive to benchmark Visione. And actually Visione embeds the powerful of the CLIP architecture and in general cross-modal retrieval architectures that enable us to search for videos by using a simple textual query. Okay, or we have also some systems that within Visione that enable us to search for the keyframes of the video by using a canvas-based interface. Okay, and we retrieve, of course, many relevant results. And we are happy about Visione. We won the Video Browser Showdown challenge that is a yearly based challenge that is kept in which participate a lot of other video retrieval systems, and we arrived second in one category, and first on another category, so we are quite happy. I'm not going into the details about that, but what we would like from Visione to extend Visione to the next level is, for example, some kind of really interactive approach that goes beyond CLIP and its capabilities, that, for example, enables some, for example, LLMM augmented browsing. So we can imagine to include a chat-based interface within Visione just to ask some questions about not even videos, but even whole collections. So for example, we can imagine to ask what's the name of the groom that falls in the pool. So we have to search for the exact video in which this happens, and then to understand the clues that drive us to understand what's the name of the groom, or the actual groom within that video. So a really complex task that mixes generation and retrieval. And okay, we have other examples in which we see that we would like also the system to output us, for example, the temporal and spatial groundings of the evidence of the answer. So the actual problem relies in the computational problem, first of all, because large multimodal models are not able to compute long sequences, because large multimodal models as of now rely on transformers that have a quadratic complexity with respect to the number of input tokens. And of course, we have a data problem, that is we cannot train and evaluate fairly those kind of systems, because we lack enough data sets for training or evaluate them. And so the consequence of that is that these systems have a lot of biases and hallucinations. Okay, so the long-term goal from this little project is a very long-term goal. So we would like to give video processing tool the ability to interact and dialogue with the user for better understanding the media in a huge collection of videos. But the road is still long. I listed here some required skills. This is my personal list of non-exhaustive list of required skills by large multimodal models that help us solve some of the example queries that I show in the example before. And so, for example, reasoning on temporal relations between distant events, it has to be robust to cultural biases for diminishing to augmenting, let's say, the fairness of these systems. It has to able to access factual external data, but also be attend to specific internal clues within the video. So access external data, but also access other parts of the same video. And okay, then summarization and counting capabilities that maybe already large multimodal models have. But coming down to our objective for this mini project, we actually wanted to create a little benchmark for evaluating large multimodal models on complex, eventually factual understanding of long videos. So we focused basically on the first two elements of this list. So reasoning on temporal relations between distant events, and even a little benchmarking the robustness to cultural biases. And how we did this? We prepared a benchmark built of video sequences of some tens of seconds length. And we prepared some true-false questions that require the model to understand the relationships between distant events, distant in time events. So, for example, is it that true or false that the statue of the seated figure appears in the video before the blue plastic chair with simple design? So a human could probably solve this by taking the video and seeking the video for trying first the seated figure and then the blue plastic chair. Okay, it's not a so simple task, but a human can do this. Okay, in fact, at the first glance, it may seem a quite easy task, but little spoiler that Giovanni will tell you in a moment. This is very complex for state-of-the-art large multimodal models and also state-of-the-art clip-based models. So they are quite paragonable to a simple random coin toss, or little better than this, but very, very scarce performance. So without any further ado, I will shift the floor to Giovanni that will explain better this benchmark. Thank you.
Yes. I give you now the moderator role, Giovanni. Okay. I hope it works as we go back to. So I now give you, Giovanni. You see, then disappears the presentation. Can you now call it up again, or shall I go back? Yeah, perfect.
No. You should.
We see it.
I don't know.
Perfect.
Okay, but you see my screen.
Yep, we need now full presentation modus.
Okay, give me a second.
That's possible. Coming. Perfect.
Okay. So thanks, Nicola, for doing the presentation until here, and I will go further. So I will actually show you how we try to address this issue of benchmarking large multimodal models. in the setting that Nicola just showed you. So what is that our goal as Nicola mentioned, is that of benchmarking the ability of large multimodal models to understand what is happening in a video. But as he mentioned, one of the use cases that might be interesting is that of personal collections. Now, generally, for this kind of collections, I will have absolutely no information or metadata. Like, I can, of course, write them down and do it myself, but in general, likely I will just be recording the videos, and eventually I might be interested in having some summary of information of all the videos that I took in a vacation, for example, without having annotated anything myself. So we try to build a benchmark that follows this format, in that we start from a collection of raw videos without any annotation, and want to output the true-false questions, as Nicola mentioned, that are essentially entirely extrapolated through models. We don't make use of any information besides that is shown in the videos. And to do this, we will use, let's say, binary approach, where first existing models are used to extract information from vision to actual text. And finally, we have human annotators validate what we generate automatically in this way. So first of all, as I said, we start with annotated videos. Which videos do we pick? Are a set of videos called city videos, which have been previously used in other studies, that are essentially very simple. It's just a person walking across a famous city, famous by like touristic standards. These are all cities that are very well known. You can see the list in the slide. There is Amsterdam, Bangkok, Chiang Mai, Istanbul, Kuala Lumpur, Stockholm, Venice, and Zurich. So all cities that have touristic relevance. And these kind of videos are very, let's say, they have several good qualities that are make them fit for our use case, which is we can be confident there is no harmful content, as is just a daily walk across the city. There is a plethora of scenarios, different places, images, cultures, even going across different cities. So several different things are displayed, and they are chaotic. So that's what makes this benchmark very difficult. Essentially, anything can happen in this video. There is not really any reason to believe that given events will happen before or after others, because there is nothing is being portrayed. It's just what happens in front of our recorder. And these are also, well, they're also very long videos, like they can last up to 1 hour. And so we start from this collection, and we essentially make up a pipeline to address the first part of the data creation, which is starting from only video, coming out with questions about the same videos. And to do this, we let's say, use a 3-step pipeline, where first step is just segmenting the 1 hour, 2 hours long video of a whole walk across the city into shorter ones of 20, 30 seconds. After that, we pick few frames from each video. Each of these frames is, let's say, captioned or given a description through a model, Lava, which is specifically meant for this. So for write the description of what is happening in an image instead of a video. And then after we have the description of 3 frames or 4 frames across our video, we use a new model, Llama, which is text only, to put all the facts that Lava has told us happen in the frames together in a true-false questions that is meant to ask what happens first and what happens last. So we are focused on testing, let's say, temporal understanding, of course, inherent to the fact that happened in the video. So if something doesn't happen, that's also being tested. But the question regards the temporal happening of events. And so this is the outcome of this process, is these raw data sets that further will be validated by humans. Since this is all automatic, here I show you just some numbers that are meant to let you understand that we can collect a very large number of videos from just of these shorter videos with questions from all the city videos. So for example, we can, as you see here, we can collect thousands of videos and tens of thousands of questions, and these questions can also be augmented further because language models can be used. Lava can be used to generate different description, and then Llama can be used to aggregate description in different ways. So this, let's say, raw data, which will not be perfect, can be scaled up to very large numbers. After this, we come to the human evaluation part. In this, we use two separate platforms, one to actually expose the question to raters, which is quest-based, and essentially it shows video with the question, and I will show you later how it looks from the annotator perspective, and Prolific, which instead is the platform where we actually recruit the annotators. And these two platforms together are the, let's say, the last part of the pipeline that we set up that let us get a cleaner version of the data sets compared to what we get only using models to generate questions. And here you see, as I was saying, an example of what an annotator is shown. So essentially there are 5 questions about the video, and then each person is asked to watch the video and answer the questions as well as they can. They can not only answer them as true, false, but there is also a third option, which is I don't know, which they are instructed in the beginning to interpret as those questions that are inappropriate for the video, or that anyway cannot be answered just looking at the video that we are providing them. And here, if the presentation goes along with me, you get to see what is the, let's say, the final outcome of one of these, of this whole annotation pipeline. So on the left, you should be able to see a question, and on the right, you see the video, which is the video that you've been seeing all along this presentation with the possibly Buddha and the blue chair, and you will see how it actually looks as a video right now, hopefully. And it went black. Nobody's. Can you see it?
I see it. I see it. No?
Okay,
Everything
nice,
is fine.
nice. And so, as you see the question, the person moves along the video, now sees what is the first part of the question. Now there is a clear simple blue chair, and then the short video slowly comes to an end. And this is essentially, you get a pretty good feeling of how an annotator, of what an annotator had to do, and also of the actual questions and answers that will be shown to the model. So what happened? What's the results of this annotation pipeline? We have currently annotated approximately 800 videos, and each of these video had questions, and 5 questions, and each has been seen by 5 different annotators. So we tried to use several annotators to get improved quality for the videos, for the questions that we eventually keep. And here you see how there is a reasonable level of agreement between annotators, with the exception of Istanbul in this case, of Singapore in this case, I think, because sometimes the video are very chaotic. Some parts of the video, there are so many things happening at once that it's really challenging to answer, to understand if the question is answerable through the video. And so that's when the annotators have a hard time and essentially guess a bit. And we discard these cases, of course. As Nicola, so we come to the spoiler that Nicola made hopefully about 10 minutes ago now, and where you see that both using a clip to try and answer the question, as well as using a video language model, Video Lava, they are generally slightly above chance. So this proves that our benchmark is very challenging. And we have so far collected 266 questions that have been not only they have been synthetically generated, then validated by human raters on Prolific, and then even further, they have gone through a second evaluation from our side, because these videos are very, very complex to look at, to understand what is going on in them. And so this reflects, since we are developing a benchmark, this is a positive fact because it's very challenging and it has a lot. I mean, there is a lot of room for improvements from video language model while trying to answer our questions. And to conclude, so we have generated a benchmark, which is currently composed of 266 video questions, but that we are still growing to this moment. Of course, there are some limitations to our pipeline, and first and foremost is that there is, let's say, a roof that cannot be surpassed, and that's based on the ability of LAVA and LLAMA, which are the models that we use to generate synthetic questions, and in fact to extrapolate information from the videos and furthermore to put them into a question format. But luckily also these models are getting better day by day, and image models like LAVA are currently much more powerful than video models when describing single frames. So there is a lot of room for improvement in that sense, and this allows us to further develop this benchmark. And instead, there is a limit on the human annotators, which is that they are the question is very hard, so it's a bit hard to have them to actually agree on what the right answer is. That's why we also did a second review that we did ourselves of the data. And what we want to do is keep growing these data sets, adding landmark information. So for now, the short videos that we pick in the longer videos are just randomly sampled. We want to make them so that the person that goes around actually sees relevant parts of the seed that we can know in advance, so that we can ask questions that are grounded in this information. And then further, let's say, increase also the benchmarking that we have done so far to see the performance of other models. And thank you very much for listening to me, and even more to listen to Nicola. And if you have any questions, I think we're both open to answer them.
Yes, thank you. Thank you, Giovanni. Thank you, Nicola. Very interesting. I ask also the audience, please send us questions. In the moment, we have not yet any, but it's normal because the presentations go on. We will have a second presentation now, but please feel free, send us your questions, and after the next one comes the Q&A session. So that means I will now introduce the third speaker, but the second presentation, so not to confuse anybody here. And the third speaker is Roberto Gallotta from University of Malta, and shortly I will introduce him. Roberto is a first-year PhD student at the Institute of Digital Games, University of Malta, researching dynamic, evolutionary computation and mixed initiative co-creation for the aid of video game designers. Prior to joining the Institute of Digital Games, he was a junior researcher at Araya, the company in Tokyo, for a year. Great to have you here. And the presentation is called LLMAKER An LLM powered design assistant for video games. And now I will give you the moderator role. One moment, so you can hopefully see a pop-up video. Yes, we see already your presentation, and we are excited to listen to you.
Thank you, Carmen, for the kind introduction. Yes, I'm Roberto Gallotta, and I'll be presenting LLMAKER, which is an LLM powered design system for video games, which is a project developed at the Institute of Digital Games at the University of Malta. So a slide overview of the presentation, what we will cover. First, an introduction on video game design tools, then large language models, and then finally LLMAKER itself, and some conclusions and some references. So video game design tools are basically programs that designers use to create their video games. They're most commonly level editors or content creations. And we focus on co-creativity, which is when the designer and the computer collaborate into creating content. But this is not an easy thing to achieve, especially with computers, because mostly they lack creativity. Historically, we started with basic editors, which are everything is done by the user, and they use static assets. So the most common examples are level editors. But then we can integrate feedback into these tools. So for instance, in Sketch, they use simulations to give feedback to the user in terms of, I don't know, the complexity of the map, the symmetry. This was an FPS game, so the balance of the level if it were played by humans. And moving forward, you can also have suggestions given back to the designer. So while they are, in this case, drawing the game map, the computer can also generate new maps that can be better in some terms or another, and the user can integrate the suggestion into their own map. This is where we're currently stuck on, and the question is, what can we do next? And the answer is probably LLMs. We've seen that LLMs are capable of some level of creativity, so it could be nice if they are integrated into such tools. Moving forward, another issue with most UIs for content design tools are they are full of buttons, slider, text boxes. It's a lot of things that can hinder the creative process of the designer. So all this clutter actually means that the designer has to learn the tool in order to be proficient. This is a ramp that the designer has to go through before they are able to generate whatever they want to generate, whatever they want to create. So we assume that something more simpler than just a bunch of buttons can make them more proficient. And we get ask ourselves, maybe language, because when you collaborate with a human, you don't click buttons, you ask them to do stuff, you ask for feedback, you suggest ideas, and you get some feedback in return in language. And well, large language models work with language, so they may fit well. And this is what we try to answer with our project, which is LLMAKER. A short note on LLMs itself. As I said, they work on language, mostly text. They also can work with media, as we've seen in the earlier presentation, but most LLMs work with just language. And the way they work is they have an input, which is composed of a system message, which usually gives some context, some domain knowledge to the model, a conversation history with the user, and finally the user message that needs to be completed. The LLM takes all of this and creates a response, which is again text. And this is all fine, but what we usually have is that the text is not really content, which means that we do get a sentence back in English, usually, and that's fine, but we can't really use it directly to create content for video games. So what we want really is structured data. And some language models are actually now able to generate data such as JSON or YAML with some level of, they can do it, not always though. So another thing that we care about is having constraints in the content that we generate. For example, we can specify a constraint in natural language, and that can be translated into a proper grammar with symbols, but this still needs structured data to be represented correctly. So in the first set of experiments that we did, we tried different ways to enforce structured data creation with LLMs with different prompting styles. So here are what we used. We used zero shot, which just means that we don't give any real example interactions, or we just say, hey, this is what we want to create. Can you please generate a JSON file, for example, of this, of whatever we request. Then we use few shots, which other than domain knowledge also integrates some example interactions. And this has been proven to actually be very useful for large language models because they can actually extrapolate the rules from these examples. With chain of thought, which is an extension of few shot, we also include reasoning steps expressed as if they were explained by the language model itself. Again, this gives more context to the language models in order to give better answers. Finally, we also tested function calling, which is not really prompting, in itself, it's more of a fine-tuned way to, it's a more of a fine-tuned to the language model itself. And this requires some domain knowledge, but mostly it requires the definitions of the tools, which are the functions that the language model can have access to. When we measured this, we cared mostly about why it could fail and the time, because we, on the end of the day, we want to use this as an actual tool. So we care about having responses that are as close to real time as possible. So when it comes to failure, whenever we make a request, we can have a parser fail, which means that the response generated is not structured data at all, which happens quite often actually, especially with zero shot. We can have domain failures, which means that the response is structured data, but is not complying with our domain. Finally, we can have design failures, which means that everything is fine, the data is structured correctly, doesn't go against any of the domain constraints, but at the end of the day is not what the designer requested. And for example, here we used basically a dungeon crawler video game as a domain, and we sampled test cases based on real interactions that the designer could have with such a tool. So for example, adding rooms, adding a couple of enemies, and as you can see, this is all very high level. There aren't a lot of details, and this is what we care about. We want the tool to be able to be creative in the assistance of the level design, not just creative as in create everything. So what we found from these results is that function calling is actually the only way to have all test cases completed without parser or domain failures. And also we found that function calling has the lowest response time, which means that it can be used for real-time applications. And this is because when we generate the prompts, we don't actually generate or regenerate the entire level every time, making it more complex as time goes on, but we actually just call the single functions. And I will give a better example of this shortly with the actual application, because what we found is that function calling worked great, so we decided to go ahead and use it in our application. So finally, we go to LLMAKER itself. So LLMAKER, as I hinted earlier, is a tool for game content co-design that works essentially just on chat interactions. It's an assistant for designers, and it can be used by either novice or advanced designers because it's just natural language. So everything that the user asks can be processed by the language model, either if it's very complicated or either if it's very simple. And what is it for? Well, we are using it to create levels for Dungeon Despair, which is a game that we are developing at the Institute, which is a reverse dungeon crawler, which is loosely inspired by Darkest Dungeon, which is a popular video game from 2016. And here I have a short demo of how our designer could use it, and then I will give better explanation on how it works. So now we will just focus on the previews, and these are the user requests that appear. The video is edited for brevity's sake, but this is what happens. So the user asks questions, make requests, and the language model generates the content, and then we have a separate system using Stable Diffusion to generate the graphical assets. And the language model is able to correctly process requests that also involve some logic or dependency in some context awareness, and also changing properties entirely and following whatever the user asks. Okay, so how does it work? So again, function calling basically means that the language model can decide whether to use a tool or not. So if the user simply asks a question and it doesn't need to use a tool, then the model simply generates a response. So in this case, the level stays the same, and the language model just says, I can help you design levels for the game and give some more details. But now assume that the user makes a request that actually needs to be processed. So he wants to add a goblin to the room, then the model understands that it needs to call a function. It calls a function, then this is the message that it actually generates So it uses the name of the function to use and all the parameters that needed to be processed by the function executor. The function executor runs the function, and it either returns a success message or a functional error back to the language model and updates the level itself. Then the language model takes the output of the function executor and rephrase it a bit for the user. So it says, I've added this, instead of just saying that the goblin has been added. And the level preview is updated as well. And since we are working with language models, we wanted to have non-static assets, which means that we wanted every asset to be generated on the fly. Whatever the designer wants, we can try and make. And this is, for example, a pipeline to generate a simple character sprite starting from Stable Diffusion. And all of this starts from the entity name description, room name, room descriptions, which are provided by the language model or are inferred by the user request. So in conclusion, LLMAKER is this new paradigm for co-creativity because it's based on natural language, but it's not complete, obviously. We want to explore more modalities. So far, we only have text, structured data, and graphics, but you also would like to explore sound or experience. By that, I mean the actual process of going through the dungeon. And the question that we are saving for later, and we want to explore further, is how much creative freedom can we actually achieve via language? Which by that I mean, can we only use language? Do we need to have some buttons? Is actually language maybe worse than using buttons? We don't know. We want to see. And it's, I personally think it's an interesting question that we need answering. This is a list of the references used in this presentation. And thank you. That ends my presentation.
Yes.
And if you have any questions, I'd be happy to take them.
Thank you very much. Also, this was a very exciting presentation. And now it's time for questioning. So once more, also to you out there, please send us your questions and we are ready to answer. And I start with a question which I received from Oliver Poitou. This is for Giovanni and Nicola. So for the first presentation, what rules knowledge do you have to single frame description? Again, what rules knowledge do you have to single frame description to take into account the fact that they represent sequence of the same scene? Sorry, I meant, do you add, and I'm taking about linking information extracted by Lava based on single frames, for example, to integrate that two persons on a frame are the same as on the following one. Did you get that question, or shall I read?
Should I answer, Nicola, or do you want to? Can you hear me?
Yeah.
We don't have those. We don't have any rule of this kind, and we just want to. We rule them out. The goal is to have the questions where this is not. Where not taking this into account results in a problem for the questions. Then those we want to eliminate them. I hope this is an answer to the question. So we don't have active in place ways that makes. That rules out the case when the same person in two frames is addressed by the model twice, but those will be the, let's say, ambiguous questions that we let the annotators rule out through the third option, which is, I don't know.
Okay, thank you. Hope your question is answered. And now comes, I think, already for Roberto, but I might be completely wrong. Could you explain the metrics more in details, like the parser fail for
Yes.
Heidi?
Yes, I'll just explain without the presentation, if that's fine. The parser fail means that when we receive a response from the language model, it's either natural text or it's a non-valid JSON. So we ask in the system prompt you always return a JSON, a valid JSON data. Sometimes it doesn't really do it. We tried even changing the temperature or the optic probability a bit. That doesn't always solve the issue. So that is one failure case that can always happen with some probability with the zero shot, few shot, and chain of thought event. So we are basically relying on a JSON parser and whether the JSON parser can actually parse the JSON from the content output.
Okay, thank you. I hope, Heidi, this is an answer. And now from Robert to Roberto. Has Roberto worked on generating maps of levels or mazes? And if so, has he worked on spatial reasoning, considering left, right, ahead, behind, etc.?
Yes, so we do have some very basic geometrical representation of the map, and you can actually ask the language model to add in a certain direction. This almost always works, even with function calling, but it's not a guarantee. Function calling is great at calling functions, but obviously it sometimes can still fail to generate the right parameters, even if they are specified by the user, or maybe just hallucinate some stuff, which is unfortunate, but it's language models.
Thank you.
I hope that answered your question, and thank you for the question, actually.
Yes, so please send in. I have now questions also for Nicola and Giovanni. On one side is, well, in this world, what you showed, is there a hope one day that there will be no human annotators? I mean, Nicola, you showed this browser, video browsing tool, future. Is there a hope? You see hope? I mean, it's.
No, okay, I take this question. Well, there will be for sure humans in some way always somewhere in the pipeline, I think. So this tool is just as any other, I think, AI augmented tool, some sort of augmentation for humans to arrive better and faster to a solution. But I think we will never be able to substitute completely humans, and hopefully, I think, yeah. So at least humans will be present even in the annotation part for the dataset that will be used for training, and also during the inference phase. In that case, with Visione, is the human that interacts with the system for searching the stuff that the human want to find. So yeah, I think AI will never take the control of the world in that sense. Yeah.
As we have to also have, like, in the future, news, no, generated by our AI. So it's in the moment. Okay, this was my question, and I have also a question for Roberto, because I must say it's my personal interest. I'm in a research project, EIC Pathfinder, where we dancing online worlds, like massive online gaming worlds, which are for dancing. And there we dream of generating these dance worlds on the fly. It's like basically to make that any kind of person comes in, like in Roblox. Roblox is a good example. The kids come in and they take their own avatar and their own world, and then they can play. Can we use your tool to on the fly generate worlds?
That's a great question. I mean, as long as you can represent it as structured data in some sense, and you can have some way to go from text to that data, then I guess you could. I don't know how difficult it would be, honestly. I assume it would be quite difficult, but who knows? Maybe you can. So yeah. I don't have a definitive answer.
Yes, just like it interests me because I'm just there and we are dreaming of that there's a person just coming in. I want nice plans and I want to feel like in Sicily and I want to dance around. And then this whole thing just generates this fantastic world and I want to look, yeah. So anyway, open question. Emma, do you have a question? Emma?
Yeah, also for Roberto. How does LLM work? Like, for example, can you just write down, I want this and that, or like how specific you have to be for, you know what I mean?
In our tool, you mean, or in general? Sorry, in LLMAKER itself, or in a more general sense?
Yeah, general.
In general, okay. So usually, if you use tools like ChatGPT, which is everybody has access to it nowadays, you can be quite non-specific. And the nice thing is that by having the model that keeps some memory of your conversation by looking back at the actual conversation itself, you can refine your request further. You don't need to be extremely specific straight away. You can be a bit more nebulous with your request, and then based on what the LLM produces, you can say, okay, but what if I actually want this particular thing as well into my request? And we use this actually in LLMAKER itself. We have a pretty standardized system prompt that also defines the domain constraints. But whenever the LLM is making some failures, we do give feedback back to the LLM, and the LLM can actually do another function call, so it can try satisfy the design request again by integrating whatever feedback we provide. So if there is something that is unclear or is some slight misunderstanding, it could be refined back by either language model or by the designer asking, can you please change it in this way, even if it's already been processed.
Okay.
Two more, and then we are ending our session today. 2 questions came in by Wouter and Robert, not once more, and then we are basically for today finishing our Q&A. So Wouter, to Roberto, how did you train the system to distinguish requests that should be answered directly by the LLM from requests that should result in a function call? What is the success rate of the resulting model?
Yes, so spoiler alert, we didn't train it. The nice thing about paying money to OpenAI is that we get models that are already trained for this kind of thing. So when you provide the language model with a tool definition, which is basically saying, this is a function, it's called this is its fact, these are its parameters, the language model is capable enough to understand when it actually needs to be processed based on the user request. As far as fail cases, I don't have specific numbers for this, not on me at the moment anyways, but it can happen. It can happen especially when you say something that also includes some, let's say, trigger words for the function to be executed. So for example, if the user says, can you explain to me how creating a room with this setting, with this many enemies work, the language model may interpret that as, oh, the user wants to create a room, not actually just an explanation. And this doesn't happen often. And we did find that by lowering the temperature actually of the model itself, we reduced the amount of this thing happening. So I hope it's clear enough. But yeah, we didn't train it, and it's pretty decent using GPT 3.5.
Okay, thank you. And last question by Robert to Giovanni. It's your last one. Have you been able to automate the benchmarks? LLMs answer in different ways, and it can be difficult to find good prompts that give consistently formatted answer patterns. Do you have any comments or tips?
What we do for this evaluation, so we did in the end, we use a single prompt, which is optimized essentially by trial and error. But what we do on the other end is we only look at the, let's say, likelihood of the answer. So we only see if the model, once it's asked the question, will assign a higher probability to the answer being true or higher probability to the answer being false. And this is not, I mean, this is of course sensible to the simple prompt, but given the prompt, it's consistent. It doesn't change every time. We could differently evaluate the model by actually having it answer in natural text the whole question, and then it would actually probably change it depending on how we decode the text. But that's much harder to do systematically, and so we prefer to go with this likelihood-based approach.
Thank you. So that's it. Thank you very much, everybody. And I hope that you all have a wonderful afternoon, a great summertime, and thank you once more, Giovanni, Nicola, Roberto from Italy, and Emma from Germany, and all the participants from everywhere. And please come back next week to the last AI Cafe for quite a while. And then it's anyway summertime. So thank you. I sent you the recording. Don't forget to check your email and give me either green or red light. The speakers are the deciders if we can publish or not. Only upon green light, there will be available recording in on the AI for Media website in the AI Cafe on YouTube. So bye-bye, everybody. See you.
Thank you very much.
Thank you so much.
much.